Alright, welcome back to dividing fractions. So now that you know how to actually divide fractions, we're going to focus on dividing fractions from a word problem. And much like what we did when we did multiplying fractions within a word problem, we're going to follow some annotation steps, and I'm actually also going to show you some keywords to look for. So how do you know if it's a division word problem? First of all, please remember that these are some guidelines and that these will not be apparent in every single division problem because it's just impossible. But these are some things to look for as you review word problems. So the first thing that you want to look for is the word problem asking you to split something up into groups, into teams, into sections, into rows of some sort? So dividing 7/8 gallon of water among 3 people. 5.5 pizzas shared by a party of 12. Okay. Second thing to look for, how much can be made from something? So if I have this amount of something, how much can be made from it? So for example, 3.5 pounds of fruit made into 7 salads. How many dresses can be made from 2 3/4 yards of fabric? Okay. Now, both of these things have to do with taking one thing and dividing it among other things, which is why it goes back to being a division problem. Now, this slide should look very familiar to you, but I do want to review it. What we're going to do is we are going to read the problem once. We're going to highlight the question in one color, which is going to take all of 5 seconds. And then we're going to go back in another color or in a different type of underline, and we're going to find the operation somewhere in the problem. And it could be a keyword, it could be a hint of some sort, it could be a whole sentence somewhere that hints to us that it's a division problem. And if it does help us, we're going to draw a picture. Now, I will say that division problems are probably the hardest type of word problems to solve. And I'm going to tell you why. This is the key question. Oftentimes students have a very difficult time once they determine, oh, hey, it's a division problem. They can't decide which number goes first. Is it 3.5 divided by 4.5, or is it 4.5 divided by 3.5? And so I need you to ask yourself this question when you're trying to figure it out. Which number are you chopping in half? Are you chopping into parts? So let me ask that again. Which number are you chopping into parts? Whatever number you are chopping up into parts is the number that will go first, okay? So how do you share 8 pieces of pet pizza with 3.5 dogs? Well, what is it that you're chopping up? You're chopping up 8 pieces of pet pizza, okay? So it would be 8 divided by 3.5. Now, you really can't have half of a dog, but that's a different story. We're going to continually ask ourselves, what number are we chopping up? So let's take a look at our first problem. All right, so Ramon is making party favors. He's dividing 3/4 pound of almonds into 12 packages. How many pounds of almonds are in each package? So I went ahead and I read the question. I'm going to go ahead and highlight the question, and it's asking me how many pounds of almonds are in each package. Now I need to go back and determine, where is it hinting at my operation? And sometimes, remember, this requires that I sort of reread the beginning of the problem. Ramon's making party favors. He's there was a key word for me. Dividing 3/4 pounds of almonds into 12 packages. So that's important for me anyway, into 12 packages, because that tells me it's going into separate groups. So I've now determined that my operation is division. But then, here's the hard part. Is it 3/4 divided by 12, or is it 12 divided by 3/4? So, what is being chopped up into parts? Are the packages being chopped up into parts, or is that 3/4 pound being chopped up into different packages? Well, I am taking this 3/4 of a pound and I am dividing it. I'm chopping it up into the different packages. So it's 3/4 divided by 12. And what I'm going to do is I'm going to use that, and I'm going to make my tic-tac-toe board just like that. And I'm going to pop my 12 over 1 there. I have keep, change, flip. I'm going to keep my 3/4, change my division to multiplication, and flip my 12 over 1 to 1 over 12. I could multiply straight across, but I like to cross cancel. So I see that my 3 and my 12, my 3 is on top, 12 is on the bottom, and I know that that would simplify to 1/4. So my 3 becomes a 1, my 12 becomes a 4. So now I can multiply straight across. 1 times 1 is 1, 4 times 4 is 16. So each package is going to have 1/16 of a pound. Great job. All right, so to tie-dye one t-shirt, 3/8 cup of dye is needed. There is 3/4 cup of orange dye. How many t-shirts can be made using the orange dye? So the first thing I'm going to do is I'm going to go back and I'm going to highlight my question. How many t-shirts can be used making the orange dye? The next thing I'm going to do is I'm going to find my operation, and I'm going to have to reread the problem probably once or twice more. So I'm making one shirt. So to tie-dye one shirt, 3/8 cup of dye is needed. There's 3/4 cup of orange dye. How many shirts can be made? Okay, so it looks like for one shirt, I need 3/8 cup of dye, but I have 3/4 cup of dye. Okay, so how many shirts can I make out of this 3/4 cup? Which just answered my next question automatically. What is the number that I am chopping up into pieces? Well, I have this much orange dye. How many shirts can I make out of it? So 3/4 divided by 3/8. And I'm going to go ahead and divide that. So I have keep, change, flip. So I'm going to keep 3/4, change division to multiplication, and flip the 3 over 8 to 8 over 3. I'm going to go ahead and cross cancel. I see these 3's here can completely go away to 1's. And I see this 8 over 4 here because the 8 is on top, 4 is on the bottom. And that would turn into 2 over 1. So that would be a 2 and that would be a 1. Which means 1 times 2 is 2, 1 times 1 is 1, which is simply 2. So how many shirts can I make? I can make 2 shirts. That's my answer. All right, let's take a look at another question. The recycling center shreds 7/8 ton of aluminum each day. The machines can shred 1/24 ton of aluminum per cycle. How many cycles will be needed to shred the aluminum? So first thing I'm going to do is highlight my question. How many cycles will be needed to shred the aluminum? Second thing I'm going to go ahead and do is see if I can find any keywords. Let's see, this per cycle tells me that multiple cycles can run. Let's see, the recycling center shreds 7/8 ton of aluminum each day. So this each day and per cycle tells me things are happening repeatedly. Okay, so I know that I'm going to have a division problem. Now my question is it 7/8 divided by 1 over 24 or 1 over 24 divided by 7/8? So I'm going to read it one more time. The recycling center shreds 7/8 ton of aluminum each day. So over the whole day, they shred 7/8 ton. Now the machines can shred 1/24 ton per cycle. And obviously they run many cycles per day. So how many cycles do they shred in one day? Okay, so it's going to be 7/8 divided by 1 over 24. All right, so we're going to do keep, change, flip. So we're going to keep the 7/8, change division to multiplication, and flip 1 over 24 to 24 over 1. I'm going to go ahead and cross cancel. I see this 8 and 24 can change into 3 and 1. And then I'm going to multiply across. 7 times 3 is 21. 1 times 1 is 1. which comes out to 21 cycles. All right, at the end of the night, the Pablo Palace Pizza Place has 3/4 of a pizza left over. The 2 employees each took home the same amount of pizza. How much pizza did each employee take home? Okay, first thing I'm going to do is highlight my question. I need to know how much pizza did each employee take home. Second thing I need to know is where are my keywords, okay? So the 2 employees each took home the same amount of pizza, which means it was divided into groups of some sort. So you may say, well, there's only one number here, 3/4, but this is a number here also, 2, okay? Just because it's spelt out does not mean it's not a number. Is it 2 divided by 3/4, or is it 3/4 divided by 2? Well, what is the item that I'm chopping up? Am I splitting up the pizza, or am I splitting up the employees? I'm splitting up the pizza, so it's going to be 3/4 divided by 2, and you know that I put that 2 over 1. I'm going to make my tic-tac-toe board. I have keep, change, flip. I'm going to keep the 3 over 4, change the division to multiplication, and flip the 2 over 1 to 1 over 2. I'm going to multiply straight across because it does not look like I can cross-cancel anything. 3 times 1 is 3, 4 times 2 is 8. So I end up with each employee gets to take home 3/8 of the pizza. All right, Jen has jelly beans that weighed 6 2/3 kilograms. If she wanted to split the jelly beans into 5 equal groups, what would be the mass of each group? So let me go ahead and get my highlighter here. So here's the question. What would be the mass of each group? And where are my keywords? I saw some keywords. Split the jelly beans into 5 equal groups. For sure, that is signaling some division. Here's one number, 6 2/3, but my other number is also spelt out right here. It's 5. Now, is it 6 2/3 divided by 5, or is it 5 divided by 6 2/3? Well, what is it that's being chopped up? Am I taking all of the jelly beans and separating it into 5 groups, or am I taking the 5 groups and separating it amongst 6 2/3 jelly beans? The first answer is correct. So I'm taking the 6 2/3 jelly beans and I am dividing it into 5 groups. Now I need to change this into an improper fraction. 3 times 6 is 18. 18 plus 2 is going to be 20 over 3 divided by 5 over 1. And we'll go ahead and do a tic-tac-toe board. It's a very slanted tic-tac-toe board. Keep, change, flip. So we're going to keep the 20 over 3. We're going to change the division to multiplication, and we're going to flip the 5 over 1 to a 1 over 5. It does look like I can cross cancel here. So I have a 20 up top and a 5 on the bottom. 5 goes into both of them. 5 goes into 20 4 times, and 5 goes into 5 1 time. 4 times 1 is 4. 3 times 1 is 3. So your answer is 4 over 3, but I also want a mixed number. 3 goes into 4 1 time. Okay, it goes in 3. And the difference between 3 and 4 is 1, and I keep the same bottom. All right. That is the end of the division word problems. Once you get a hang of which number goes first, they are not too bad. Make sure you ask me any questions you have in class.